Summer concerts, pool parties, chill nights under the stars. We're stocking up our closet so you're ready to look your best for all of it. At Plato's Closet in West Ashley and North Charleston, we're buying all things summer. So bring in your tees, tote bags, sandals, sunglasses, and more. We pay cash on the spot for gently loved name brand looks. Plato's Closet is the go-to destination for trend-forward teens and young adults who support local and shop sustainable. Visit Plato's Closet today. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
With everything you have on your plate, earning your degree online seems impossible. But at Grand Canyon University, we specialize in helping you fit a master's degree in business into your busy day. Your graduation team, led by your own GCU counselor, provides you with the personal support you need to succeed. Achieve your goals with a plan and team behind you. Find your purpose at Grand Canyon University. Visit gcu.edu.
Hello, everyone. This is Gabe, your humble host of the Breaking Math podcast. Autumn and I are actually out this week, but we have a wonderful guest host for today's episode who's doing a wonderful discussion on something called the 10,000-year problem. That is, how do we communicate the dangers of nuclear waste stored in places where it might not be discovered by civilizations until far in the future, let's say 10,000 years? It's a fascinating discussion. This is a time where we can't assume that they still speak English or that they might understand our symbols for dangers. Our guest host today is Mr. David Gibson, who is the CEO of a science communication channel called Ray Kitty Creation Workshop, and it's actually named after this problem as well. So more on him in just a bit, but first I've got some amazing announcements. Who enjoys reading books about science? Our podcast has been sent a couple of books recently, actually 4 or 5 books, and we have been given the opportunity to read through the books ourselves and interview the authors of the books before or soon after the books have been released. I want to tell you a little bit about these books. The first one is called Gravity of Math: How Geometry Rules the Universe. This book is published by Basic Books of New York. This is a book specifically about math and gravity. It's everything from Isaac Newton's description of gravity to Einstein to gravitational waves and more. Now, it's written by 2 people. One of them is named Professor Xing-Tun Yao. He's one of the authors, and he is furthering the development of these theories and especially how they pertain to uncertainties regarding the actual meaning of math. I mention this because here on the Breaking Math podcast, we've covered Einstein's theory a few times now, but this is brand new information. This is specifically about how there are just some ambiguities and some uncertainties about how math is defined. So we'll see how that pans out in the book. The other author is Steve Naddis. He is a contributing editor to Discover magazine and a contributing writer to Quanta, one of my favorite magazines, and he lives in Cambridge, Massachusetts. Now, I will be interviewing Mr. Naddis on this podcast, so please send me your questions. Also, we sell a gorgeous poster on the mathematics of tensor calculus, which is the math used to describe Einstein's general theory of relativity. We've got examples of that on our website at breakingmath.io. Also, if you're interested in getting a copy, just send us an email at breakingmathpodcast@gmail.com. Now, the next book, this is an interesting one. The next book is a little bit about Bayes' theorem. Now, whenever I bring that up, I have gotten a reaction that, oh, I don't like statistics. Oh, that's a field that I don't understand at all. Well, this book brings a very important part of statistics to the layman, specifically a field where things like false positives are understood, and people who are falsely imprisoned can use Bayes' theorem to prove their innocence. Also, this book describes how this theorem can be used to understand algorithms for ChatGPT and other forms of AI, which are growing in the workplace. Also, how military strategists can use the theorem to predict where the enemy will strike next. It's a very interesting book, and I highly recommend everyone check it out. The book is called Everything is Predictable: How Bayesian Statistics Explains Our World, and it's on sale starting May 7th of this year. I will include a link to where you can buy it in the show notes. It's written by Tom Shivers. That's Tom, Chivers, and he is an award-winning science writer for Semaphore, which is an international news outlet that you also check out. His writings also appeared in everything from the Times of London, of course, The Guardian, New Scientist, Wired, CNN, and more. He has other books books, including Everything is Predictable, The Rationalist's Guide to the Galaxy, and also How to Read Numbers. This is a conversation I look forward to having. I think understanding Bayes' theorem would be really important for everybody, especially anyone who you might someday need to understand that, for any reason, for understanding false positives in medicine or for legal reasons or more. The last book is a fascinating one. It's called A City on Mars. Can we settle space? Should we settle space? And have we really thought this through? And it has cartoons all throughout it. This is a book that was released a while back on November 7th, but it's out now. And again, as I said, it's got science and it's got cartoons and deep questions. It's published by Random Penguin House. Penguin Random House. Now that Penguin Books and Random House have joined, they are Penguin Random House. And the authors are Dr. Kelly and Zach Weinersmith. Where have you heard that name Weinersmith before? There is a comic strip called Saturday Morning Breakfast Cereal, Saturday Morning Breakfast Cartoons. I'm going to have to search that up and correct me on this announcement. He's a famous cartoonist who has a hilarious cartoon called Saturday Morning Breakfast Cereal. We'll call it that. And he goes back a long time. That's a hilarious cartoon. They both wrote a book that explores some of the challenges with trying to settle Mars. And they try to answer that question in deep detail. Everything from what would the human body go through in trying to settle Mars, to what would reproduction be like, to what would politics and law and governance and other things be like for the first settlers of Mars. And it's a fascinating read, and it challenges the reader to really consider these topics carefully. So goodness, yeah, that's 3 books that we've got that'll be happening soon. Now, where are Autumn and I going? We are actually off to a math cruise. It's just like a regular cruise, but instead of things like water slides and magic shows and rock climbing, it's a lot of math. It's a lot of folks doing math. Totally fun, it really is. So I hope you have a fabulous podcast and experience with David Gibson, and please check out his show. Again, it's the Ray Kitty Creation. The Ray Kitty Creation Workshop. Give him a follow, and we will see you guys next week.
Hello, and welcome to the Breaking Math Podcast. I'm David Gibson, as Gabe and Autumn are off on a tangent solving problem somewhere. They asked me to sit in today. I, as background, am not a mathematician. I am actually not all that great at math. To be quite honest, I teach science. But in science, there is so much math, and they are so ingrained and part of each other that it was very cool for them to ask me on and to ask me to help out in co-hosting or guest hosting this podcast. So today we are going to be talking a little bit about science. We're going to be talking a little bit about math. We're going to be talking a little bit about history. And I teach, as I said, science. I run the Ray Kitty Creation Workshop. I even have a show here in the wonderful Studio 519 with the awesome folks here. And it is called the Ray Kitty Science Project, not to be plugging everything there. But so science is my passion. But Gabe asked that I talk about something that I'm passionate about. And so this will have math in it. I know you tuned in for the math, so there is math in this one here. And we are going to talk about what is called the 10,000-year dilemma. Okay? So the 10,000-year dilemma is a way in a thought project or a thought experiment on how to deal with nuclear waste in the future. Okay. Now, nuclear waste is something that we are getting from nuclear research. We're getting it from medical facilities. We're getting it from nuclear energy or power generation. And so this waste that is developed there has to go somewhere. The 10,000-year dilemma is talking about, okay, this waste right now, some of this waste is pretty toxic. If we were to talk about plutonium-239, for instance, which is one of the isotopes that's readily used and normally used in some of our nuclear reactors, the waste, the plutonium-239 that they have has a very long half-life. The half-life is 24,100 plus years. So that means that plutonium is not gone in 24,000 years. That means it's reached its first half-life. Now that half-life is when half or approximately half of those isotopes have decayed. Okay. Now they may decay into and do decay into other toxic isotopes, but we're just talking the plutonium, 24,000 years for the half-life. Now, if you had a 5 kilogram little mass of plutonium-239, which would be pretty small, okay? It's a very dense material. That 5 kilogram mass would have the number of isotopes in there would be 12.5 times 10 to the 24th power. This is a math one. You can do the math on that one. That's a lot of zeros, okay? So there's that many isotopes in this that are toxic isotopes, that are radioactive isotopes. The half-life in 24,100 years, you would still have, here's a little bit more mass, 6.25 to the 10th, and then you can figure that one out. So you've got a lot of this radioactive material that you're storing for a very long time. And so in the future, the 10,000-year dilemma is deciding, how do we tell future generations, future civilizations, future cultures that this is something dangerous? Now, you may think, okay, well, what if we erect these huge monoliths and things like that? How well did that work for the pyramids? Okay, now the pyramids were meant to keep people out. And so what did people do? They went in, right? They went in and they ransacked and they pillaged and they stole and they took all of these things away from it. And so the danger in having these beautiful monoliths and things like that is that it can be inviting, right? It can say, hey, there's something here, come check it out. Now, 10,000 years into the future, you say, well, why don't you just put a big old do not touch sign on there? Now, there's a problem with that. And that is the semiotics of our language, the semiotics of our signs. Now, when I say the word semiotics, that is the study of signs, the study of language, and how they're interpreted. And we have a semiotics even in math. Okay, the symbols that we use today, if you look at Roman numerals, really about the only place you're going to see Roman numerals is knowing what Super Bowl we're watching. Roman numerals are not used very regularly, but we do, and I have an image there, and the image is of a tablet that was used in Babylon, and this is actually showing the square root of 2. Okay, now if I were to look at this tablet here, I would see a bunch of nicks in it, and it looks like maybe somebody tried to ice skate on it or something like that, because I see a rock with a bunch of nicks in it. Now, someone who can read this cuneiform would say, oh, well, this is actually the approximate square root of 2. And as we can see on there, we have our Pythagorean theorem on there. We have our isosceles triangle. So there's a lot of math that's on this little rock here. Now, of course, the numbers that are on there are notation. Those are not actually the numbers that were found on it. And that's the point. Okay, so on this image, what we're seeing is this is how they used to represent the symbols for math. Okay, now this is on the sexagesimal system, which is that number of 600, those kind of things. If we look at the next little image here, it actually shows that the images for the sexagesimal system itself wouldn't even make much sense if we were to look at those today. Okay, so those images that represent 1, 10, 60, and then go up by your sixes wouldn't even really make sense in the way that we're looking at math today. Okay, so the sexagesimal system is a system that is not used as often in mathematics anymore, and these are symbols that are no longer really used in math anymore. So this is very important, because when we're saying, hey, I want to notate do not touch, just like mathematics, our symbols for everything else have changed dramatically and drastically. And I want to actually read a little note here that was written because when they were going through this thought project, they talked to scientists, they talked to archaeologists, they talked to philosophers, they talked to all kinds of people in all kinds of fields, because it was very important that they're able to use this note for future generations. And they asked Carl Sagan. Right now, Carl Sagan is kind of my generation's Neil deGrasse Tyson, right? He was actually the predecessor to Neil deGrasse Tyson, if you talk about cosmos and those kind of things. So they asked Carl Sagan, they said, well, what symbol would you use? Now, this was a little bit later in his life. He was ill, so he wasn't able to actively participate in the project. But these were his words. He says, what we need is a symbol that will be understandable not just to the most educated and scientifically literate members of the population, but anyone who might come upon this repository. There is one such symbol. So here we go. He must have fixed it. Used on the lintels of cannibal dwellings, the flags of pirates, the insignia of SS divisions, and motorcycle gangs. And the key is the skull and crossbones. Okay, so Carl Sagan said, hey, let's put a skull and crossbones on it. No one will ever mess with it. Now, as we can see here on this cute little puppy, nowadays the skull and crossbones does not have the gravitas that it once had. We see skull and crossbones on beanie hats. We see it on t-shirts, on socks, on little t-shirts on our puppies. So it's not this heavy symbol that would say don't mess with it. In fact, it may say, hey, here's something cool, come check it out. So even though we use it on poison, and it is a symbol that is still used to represent something dangerous, it also represents exactly how dangerous this cute little puppy can be. So when we are talking about the skull and crossbones, I thought I would check a little bit into the semiotics and how has the skull and crossbones, just as that singular symbol, how has that changed? Now, the skull and crossbones actually started out as a Templar symbol. Okay, so the Templars used it, and what we know about the Templars, they were slash are, depending on your Illuminati feelings there, but the Templars were a very cryptic. They used a lot of hidden meanings and hidden messages as well as symbols, and they were also pirates. So they were all of these wonderful things. So where did this symbol come from, and how did it enter into our Templar mythology? And it was a story. The story was in the Templar Holy Blood and the Holy Grail. Okay, and so the story was that a great lady of Maraclea was in love and loved by a Templar Lord of Sidon. Okay, so the Lord of Sidon loved this lady, and she died very young. Okay, so he actually went into the tomb and, being still in love with her, carried on. You can do the math on that one as to where that went. Well, a voice came to him, and the voice from the void told him to return in 9 months, and he could retrieve his son. Okay, so the voice from the void said, 9 months, come back and retrieve your son. So 9 months later, sure enough, he goes over to this tomb. He opens up the tomb, and what does he find? In this tomb, he finds a skull lying on the crossed leg bones of a skeleton, the skull and crossbones. Okay, that was what he found in the tomb that he had opened from his, some say, wife. And so when he found this, he's, of course, distraught. But the voice came back, and the voice said, guard it well, for it would be the giver of all good things. Okay, so the origination of the skull and crossbones is that it is the giver of all good things. It was to be used as his genius, as his guide, as his forerunner. So this skull and crossbones was going to make his journeys, his conquests profitable. It was a mark of good fortune. So right off the bat, the skull and crossbones was used by the Templars as a mark of good fortune. Now, here's a little bit of semiotics and human viewpoints there. If I were to be a Templar and I were to be sailing a boat toward your country, toward your boat, and I had my wonderful giver of all good things with me, and I had that sailing on the mast, so I had this huge flag with a skull and crossbones that was my forerunner, and that meant good fortune for me. What does that mean for you? So the Templars being somewhat pirates, if you were on the other side of the boat looking at that, all of a sudden that is a message or a sign or a symbol of warning. Okay, so this went in just this very short period of time from something that was a forerunner, meaning the bearer of all good things, to a warning. Okay, so now the skull and crossbones is a warning. So this warning, as it continues through the ages, as we see now, is now just something that you put to say, hey, I'm maybe edgy, or that I enjoy, these kind of fun, dark things. Okay, so it lost a lot just in that short period of time. Okay, so the symbol for the skull and crossbones, that's out. Okay, so Carl Sagan, even being the mind that he was, didn't take into account how things can change. So in the kind of idea of things changing as far as symbols, as far as semiotics, as far as language changing, maybe they put up that big sign that says do not touch, or Sandia National Labs actually had a wonderful ominous saying that they wanted to put on there, and that was, I'll read it to you here because I want to get these words right. This place is not a place of honor. No highly esteemed local, or no, let me start with that one over again. Here we go. Let's try this again. This place is not a place of honor. No highly esteemed deed is commemorated here. Nothing valued is here. Now that is ominous. Were I to read that, I would say, okay, this is not really something that I want to or even need to mess with. The problem is that's still written word. Okay. The idea was to write it in every known language. Well, that's great. But language also changes. Language also adapts. Okay. So when we're looking at language, as I said, I teach science. I have in-person classrooms, meaning I deal with teenagers. Okay. And so you know where I'm going to go with this. Teenagers, in addition to scaring the living out of me, are also a great adapter of language. Okay, so we have new words that now, if you look on the internet, you'll see the jokes about folks my age not understanding the words of teenagers nowadays, and the words have changed a lot. Also, what about the very secret cryptic code that my mom and grandma used to write in called cursive? Okay, if I hand a note in cursive to one of my students, they're going to look at that. They are going to have no idea what that says. So even just in the generation from, say, my parents' generation to my children's generation, cursive is already something that is a lost language for the most part, a dead language. So writing these words on something is also not going to quite get the point across. Okay, so symbols, if we were to look at a culture that if it were to just freeze frame the United States right where we are right now, and a culture 10,000 years from now, if they knew nothing about us, were to say, okay, well, let's investigate the United States. Let's see what we can learn about these guys. They would think, okay, judging from what they would come across, these are some things that they may think, that possibly we worshipped bats and spiders, and that we received our nutrients from a small plastic 6-inch box in our hands because everyone had these small boxes, so they must be important to life. And we were all wearing shirts with a spider emblazoned on it or a bat emblazoned on it. We had small idols that were Batman and Spider-Man and Superman. So these must have been the icons or the gods of our era. And so you can see how this could be misconstrued very easily. And so they came up with some ideas to perpetuate the idea that these things that are buried here are in fact dangerous. Now, some of them were pretty crazy ideas. Some of them were pretty outlandish. They had if you could shoot some they called it a moon into space, right? Some satellites into space that would continually broadcast, hey, this is a dangerous area. And there's some issues with that. How would you continue to get reception from that if the culture didn't have something that was tuned to its frequency? So there's some problems with that. They also said, okay, well, what if we raised up a priesthood of the atomic or nuclear dangers, right? So because stories stick around a lot longer than our images, than our, maybe not the images themselves, but then our understanding of the images. So if we were to start this atomic priesthood, then there could be a lineage that would always tell people not to mess around with radioactive waste. Well, that has also got some, errors to it and some issues with it. So there was another idea that they came up with, and that is where I am kind of the most interested in. As I said earlier, the name of my business is called the Ray Kitty Creation Workshop. Now, that is also the name of my cat at home. His name is Ray. And that's where this next crazy idea that they came up with comes into play. They called it the Ray Cat Solution. Okay. And what it was an idea that we will genetically modify cats to where they will change color when exposed to the right amount of radiation, like this little guy here. They will change color when they're exposed to the right amount of radiation or the right strength of radiation. And so that's only half of the story. In addition to getting these genetically modified cats, what we're going to have to do is we are going to have to ingrain into society and into our culture that when these cats change colors, it is in fact something dangerous. Okay, so the reason we would want these cats to change colors is to show, hey, you're in an area where there's high radiation, get away from there. Now, stories, as we were talking with the priesthood, the stories are a way that has been historically, and even in the name historically, have been passed down, even though they're always a game of telephone where the story changes a little bit. There's the hero and the villain and things like that kind of stick around in the story, and elements of the story that stick. Now, why did they choose cats? Cats have been cohabitating with humans for the longest, as far as we know. If you look into Babylonian, Egyptian, into all of these ancient cultures, we see cats. Okay, so we see them in their imagery. It's already part of the culture. All we would have to do is ingrain it in a way that it would stick. Now, one way that you can make something like that stick would be to interject what is called the 10,000-year earworm. Okay, and this earworm is a song, and we'll play it in just a second here. And the 10,000-year earworm is a song by Emperor X, and he made this song as kind of a fun way, but he had heard about the concept, and he talks about color changing cats in a way that is a nice little jingle. Okay, so let's hear the song, the 10,000-year earworm, and then we'll talk a little bit about what we're hearing in that song.
Don't change color and keep your color if you stay that pretty gray. Don't change color till you keep your color till you keep sitting in so lame. Don't change color till you keep your color till you keep stay through the but if you little wellness, I all gonna have to know. Don't change color till you keep your color till you stay that pretty gold. Don't change color, just keep your color, I'll keep your fun but pole. Don't change color till you keep your color, cause you need your time around. Let it turn change your looks for breaking through with us out of town. Don't change color cause you keep your color, cause you know I don't know why. Don't change color till you keep your color, God said it's not right. So don't change color or flash your eyes, Lord knows if you do. I hope you think it's cozy in your travel case, cause it's time to boom. Don't change color till you keep your color, till you stay like midnight black. Radiation haven't changed, it's alive, kill it, and to fight. Radiation, whatever that is something we don't want. Cause it withers our crops and it burns our skin and it turns our white side bones. So don't change color, art. Kitty, don't flash your eyes, so don't change color. Kitty, don't flash your eyes, they all change color.
So that's an awesome little ditty, just a fun way. But the idea was that an earworm is something that sticks with you, right? So we would have to not only genetically engineer these cats to change colors, we would also have to ingrain that into culture to where we knew that that color changing kitty was a problem. And so these were just kind of some fun ideas that they had come up with. And some of them, you say, okay, well, we probably shouldn't genetically modify cats. If you look on the internet, we already have glowing cats. It's true, they work the same as they do with the tiny little glowfish. We do have some glowing cats that you can find on the internet. Another fun kind of place where they actually use that song is there's a video. If you're interested in the Ray Cat solution in particular, there's a good video. It is free access and it is from Aeon Videos and is called the Ray Cat Solution. You can look that one up. It's a short, I believe, 15-minute video. It's very well done, but it talks a little bit more about the scientists and the Human Interface Task Force, which is, no, it was a real thing. And it talks a little bit about them and how they developed the ideas, like to put satellites in space and to have these color changing cats. Okay. So what we see here is that through time, our semiotics in math as well as science can change. And so we need a way of warning the future generations. And what I like about that, because as I said, I named my business, I named my cat the Ray Kitty, Ray Kitty Project. Oh, I didn't name my cat the Ray Kitty Project. I named my cat Ray because he's a cat. And my business, the Ray Kitty Project, or science, creation science. Ray Kitty, Anyway, I named my business Ray Kitty because the idea that we as humans completely understand science and we completely understand math is just so far-fetched, right? It's as far-fetched as a color-changing cat. The idea that we can grasp everything there is to grasp about math, and that the way that we think math is now will be the exact same way math is in 10,000 years. The things we think about science will be the same in 10,000 years. I mean, it wasn't long ago that we believed in humors, the black phlegm and things like that, that were what changed our mood and our disposition. And the cuneiform, as we saw in math, these things are now in the past. Now, science and math, what I like about this Ray Kitty solution, science and math, the facts do not change. But what's interesting and so appealing to me about that Ray Kitty solution is that even though the facts don't change, what changes is our interpretation of the facts, our knowledge of the facts. And that can and will and should change as we progress. We should know more about math in 10,000 years. We should know more about science in 10,000 years. And that is what kind of with this Ray Kitty project and the 10,000 year dilemma, that's what is appealing to me. And so I wanted to kind of bring that to you guys in this math podcast. Now I know the entire thing was not wrapped around math today, but I do appreciate Gabe and Autumn being able to kind of stretch out a little bit and say, hey, because math is incorporated into all of these other subjects and topics, let's bring them in and have them be part of the discussion. So as I, Mr. Dave, when I'm working with the Ray Kitty Science Project, as I usually always end mine, one, thank you for tuning in to the Breaking Math podcast. And as I always end my media, don't forget that science and math shows.
Summer concerts, pool parties, chill nights under the stars. We're stocking up our closet so you're ready to look your best for all of it. At Plato's Closet in West Ashley and North Charleston, we're buying all things summer. So bring in your tees, tote bags, sandals, sunglasses, and more. We pay cash on the spot for gently loved name brand looks. Plato's Closet is the go-to destination for trend-forward teens and young adults who support local and shop sustainable. Visit Plato's Closet today. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
You matter.